Welcome to Study Loop.
This is the answer to Chapter 21, problem number 89 from the Smith Organic Chemistry textbook. This problem talks about Brevicomin. It's a pheromone from a beetle, and we're told that it contains a bridged bicyclic ring system, and it's prepared by the acid-catalyzed cyclization of 6,7-dihydroxy-2-nonanone. And so first we're asked to suggest a structure for this molecule. And so there are some clues here. So it's a bicyclic bridged ring system, and it's prepared by acid catalyzed cyclization of this diol with a ketone in it. And so when we think about the mechanism of what the acid catalyzed cyclization of this molecule might look like, the structure that we come up with is going to look like this. And it's a somewhat complex structure, so bear with me. So it's going to be a 7-membered ring. So 1, 2, 3, 4, 5, 6, 7. So 7-membered ring. Bridge is going to be here. Let me draw this a little better. So the bridge is going to be there, and then we're going to have an ethyl group here and a methyl group here. So this is the structure of Brevicomin. Okay, and so then next we're asked to synthesize it. We're asked to synthesize 6,7-dihydroxy-2-nonanone from 6-bromo-2-hexanone. And we are told we can also use 3-carbon alcohols and any required organic or inorganic reagents. Okay, and so we're going to start from this 6-bromo-2-hexanone. And so the first thing that I'm going to do is protect this ketone. And so we'll do that with ethylene glycol. And a little bit of acid. Okay, and so this ketone is protected now with this cyclic acetal protecting group. And this is good because it gives us the ability to manipulate the rest of the molecule without worrying about reaction at that ketone. And so we have a bromine, a bromide, and we need to add some carbons. And one way that we learned in this chapter that is an effective way to do that is going to be to convert this bromide into a Wittig reagent. And so that is done easily enough. So we're going to use triphenylphosphine and butyllithium. Okay, and so now we have our Wittig reagent here. So that's good. Ketone still protected. We have our Wittig reagent, and we need to think about what we want to add. So we're going to want to add 3 carbons. And so to add 3 carbons, we're going to need propionaldehyde. And to get there, since we're only allowed to use 3-carbon alcohols, we can basically just take 1 propanol, oxidize it with PCC, and that is going to get us right where we want to be. Okay, so now we've made that. Let's put it to use here. And so the product of this reaction oops, is going to be this. Ketone still protected over here. Let's move this down so it's visible. Okay. Let me make this a little cleaner. Go. So our ketone's still protected. And this is going to be a mixture of E and Z isomers. But really, it doesn't matter because in the next step, we're going to get rid of this alkene. And that next step, we need two hydroxy groups. And so to get those two hydroxy groups, we can do a dihydroxylation. And so a set of reagents that we know will accomplish that is going to be osmium tetroxide. And then the workup for osmium tetroxide is always this. Okay, and so that reagent set is going to do a dihydroxylation for us. And through all of this, our ketone remains protected. And so now we are here. We've added two hydroxy groups. This molecule is starting to look like our target molecule. And indeed, the very last thing that we need to do is deprotect our ketone. And so we can accomplish that with some acid and some water, some aqueous acid. And so that is going to get us to where we want to be. Okay, and so this is the molecule that we were asked to make. This is 6,7-dihydroxy 2-nonenone. And then a little more acid will get us to the Brevicomin. But this is the molecule we were asked to make. And so here it is. Here's a synthetic route to it. So once again, it's protection of the ketone, turning this bromide into a Wittig reagent, reacting that Wittig reagent with propionaldehyde to get the length of carbon chain that we need and to get our alkene in the proper place, that we can then do a dihydroxylation and install those two alcohols. And then we just need to deprotect our ketone. And that's it. Okay. And then once again, here on the first page, this is the structure of Brevicomin. And that's the answer to chapter 21, problem number 89.